Welcome back to another lesson in MCV4U. Today we'll be talking about critical points and local extrema. So here, the turning points of the function can be referred to by a variety of names. Again, they can be local maximum and minimum points, relative maximum and minimum points, and local extrema. So when we think about critical points are all the coordinates where y prime or the derivative is equal to 0. These are the points where where a local maximum or local minimum may occur. So here, if we look at the graph on the right, and if we look at the value from negative infinity going to -1, so that if we look at our tangent here, we see that there is a positive slope. Once we get to the value of -1, and we see that here, we get, again, that flat horizontal line, which means that our tangent line will be equal to 0. And here there's a change in direction, because then if we look at our slope after -1 to about 2, we see that there's a negative slope. Then once we hit, again, the value of 2, the slope is equal to 0, or the flat horizontal line. And then same thing again. Here, change of direction to the next local maximum. And so there's a positive slope, and then so on and so forth. So critical points, again, are all the coordinates where y prime is equal to 0. So all local extrema are critical points, but however, all critical points are not necessarily local extrema. So, so all local extrema are critical points. However, all critical points are not necessarily local extrema. So for example, consider the function f of x is equal to x cubed. At x is equal to 0, f prime of x would also be 0, making it a critical point. However, it is not a local extreme at that point. So when we look at this in general, when determining the critical points of a function, set y prime where the derivative is equal to 0 and then solve for x. Once you have the critical points, examine the behavior of the derivative on either side of each critical point. If f prime of x changes from positive to negative, which means that goes from increasing to decreasing, and x is equal to c, then f of x has a local maximum at x is equal to c. If f prime of x changes from negative to positive at x is equal to c, then f of x has a local minimum at x is equal to c. This would be, again, this would be decreasing to increasing. Then if f prime of x does not change signs at x is equal to c, then there is no local maximum or minimum at that particular point. Okay, so this is important when we're looking at this first derivative test here. So let's look at this first example here. It says, again, f prime of x is equal to 2x cubed plus 3x squared. So the first thing we want to do here is we want to derive f of x. So the derivative f prime of x is equal to 6x squared plus 6x. So that's the first step. Next, we want to make f prime of x equal to 0, and then solve for x. So 0 is equal to 6x squared plus 6x, and factor out a 6 here. We'll be left with x. Sorry, factor out 6x. We'll be left with x plus 1. And so here we have two answers. We have x is equal to 0, and x is equal to -1. And so those are our two critical points here. Now what we want to do is we want to put it on our number line, and then we're going to examine the behavior of each side of the critical point. So here we'll draw our number line. So from -infinity, positive infinity, and our critical points are at -1 and 0. So here we'll find a point that is here, that is less than -1. So we can sub in -2, for example. And here, 6 times -2 give you a negative answer. -2 plus 1 still is negative. Negative times negative will give us positive. And so here we see that it is increasing between -0 or -1 and 0. So let's sub in -0.5, for example. 6 times -0.5 will still give us a negative answer. And -0.5 plus 1 here will give us a positive answer. So negative times positive will give us negative, which sees that here we are decreasing. And then something greater than 0, so let's just sub in 1, for example. So 6 times 1, that will give us positive. And 1 plus 1 will also give us positive. So positive times positive will give us a positive value, which means that it is increasing here. And so here, if we think about this function, so if we graph it, so here it is increasing. When it gets to -1, so it's increasing. It's to -1, changes direction, then it's decreasing. So it gets to 0, and then it changes direction again here. So here we see that, again, at x is equal to -1, so at x is equal to -1, there is a local max. And here we can sub that value in. So f of -1 is equal to our original function. So again, 2 times -1 cubed plus 3 -1 squared is equal to -2 plus 3, which is equal to 1. So our local max here is at 1, -1 and 1. And we also have a local min at 0, at x is equal to 0. At x is equal to 0, we have our local minimum. And so here, if we sub in f of 0, again, that's going to be equal to 0. And so our local min is at 0 and 0 here as well. So if we look here at these values, so we see again that it is increasing from -infinity to -1, and then it is decreasing from -1 to 0, and then it is increasing again from 0 to positive infinity. And if we look here, it asks for the domain of this function. So here we see that it is from negative infinity to positive infinity all the way. So here we can write that the domain here is simply x is an element of real numbers, again, or it goes from negative infinity to positive infinity. Okay, so let's look at this next question here. So here it has y is equal to x to the power of 4 minus 18x to the power of 2. So here, again, the steps that we're going to take is number one, we're going to take the derivative. Step number two, so we're going to set y prime is equal to 0 and solve for roots. And then our third step here is test when y prime is greater than 0 and y prime is less than 0. Okay, so here we have x to the power of 4 minus 18x squared. So we'll take this derivative here. So y prime is equal to 4x cubed minus 36x. Here we'll factor out a 4x. We'll be left with x squared minus 9. Here we have 4x and a difference of squares. So x minus 3, x plus 3. And so here we have our three critical points. X is equal to 0, x is equal to 3, and x is equal to negative 3. So here we see, again, if we set it to equal to 0 here, so again, that's when f prime of x is equal to 0. So here we'll draw our number line, again, to test for, again, intervals of increase and decrease to see if there's local maximum or minimum. So here we can go from negative infinity to positive infinity, and we have a few points here. So we have negative 3, we have 0, and we have positive 3. So test for all of these intervals here. So here, if we sub in negative 4, so a value that's less than negative 3, so we sub in negative 4 here. Here we see that negative 4 times 4 will give us negative. Negative 4 minus 3 still give us negative. And negative 4 plus 3 will give us negative. So negative times negative times negative will give us a negative value here, which means that it is decreasing from negative infinity to negative 3 and negative 3 to 0. So sub in negative 1, for example. 4 times negative 1 gives us negative value. Negative 1 minus 3 gives us negative value. And negative 1 plus 3 will give us positive. So here we see that negative times negative will give us positive times positive, still positive. So we see that from negative 3 to 0, it is increasing. Then from 0 to 3, so sub in 1, so 4 times 1, that's positive. 1 minus 3, that would be negative. Oops. And then 1 plus 3 would positive. So, so positive times negative will give us a negative value. This means that it is decreasing from 0 to 3. And finally, from 3 to infinity, here we'll sub in 4. So 4 times 4, positive. 4 minus 3, that will still give you a positive value. And then 4 plus 3 will be positive. So here it's positive, and it is increasing. So here we notice again the change in direction between -3, 0, and 3. And so here we know that there will be local minimum and maximum. So here we know that there will be, so decreasing and then increasing. So we know that there was going to be a local minimum, x is equal to -3. And so let's sub that back into the original equation. So that f of -3 is equal to -3 to the power of 4 minus 18 -3 squared. That'll give us 81 minus 162, which is equal to -81. So here you see that there is our local minimum is at -3 and -81. We have a local max here again, so it's increasing from -3 to 0, and at 0 it changes direction and decreases. So we know here that there's a local max at x is equal to 0. And so if we sub in f of 0, that will still give us 0. So we know that there's a local max at 0 and 0. And lastly, again, it changes direction at 3, goes from decreasing to increasing. So we know that there's another local minimum. So that's the local minimum at x is equal to 3. So sub in f of 3 into the original equation. And so that will give us -81. So there's here again a local minimum at 3 and -81. So here, if we look at our graph, it will decrease from -infinity to 3. At that point, it will increase to 0, at which point that will decrease again to 3, and then finally increase. Okay, and so here, again, if we're looking at the domain, again, it goes from -infinity to +infinity, where x is an element of real numbers, or -infinity to +infinity. Okay, so here, if we look at C, it gives us f of x is equal to 2x minus 1 over x plus 1. And then here we can also again state the domain of the function. So here, again, we have vertical asymptote at x is equal to -1. However, you have no holes here. And so here we can state again that our domain here will be x is an element of real numbers. However, x cannot be equal to -1, because that's where the vertical asymptote is. Okay, so here, let's derive this function using product rule. So f prime of x is equal, so derive the top and keep the bottom. So 2x minus 1, the derivative of that is 2. Keep the bottom of x plus 1. And then subtract that keep the top, 2x minus 1, and derive the bottom of x plus 1, which is just 1, over plus 1 squared. So here, if we expand it out, we get 2x plus 2 minus 2x plus 2, sorry, minus 2x plus 1 here, over x plus 1 squared. So here we see that the 2x and the negative 2x can cancel out. And here we'll make it all equal to 0. So here we have 0 is equal to 3 over x plus 1 squared. Multiply that over. 0 is equal to 3. And therefore, what that means is that here, f prime of x cannot be equal to 0. And what that means is that there is no local maxes or minimums. So no local max or min. Okay, so let's look at this next example. So f of x is equal to ln x, and it says, and it also wants us to again state the domain of the function here. So here, for f of x is equal to ln x, the domain here is x as an element of real numbers, and here x has to be greater than 0. So here the derivative f prime of x is equal to 1 over x. And what we see here is that, again, f prime of x cannot be equal to 0, and f prime of x is undefined when x is equal to 0. So if we use a point here, if we draw a number line from infinity to positive infinity, and we have this value of 0, and what we notice is that, again, in our domain, from negative infinity to 0, this is outside of the domain. But we can't test for what happens when it is from 0 to positive infinity. We see here that from 0 to positive infinity, we sub in any value, we see that it's going to be positive. This means that it is increasing. So what can we understand from this? What we can understand from this is that f of x is always increasing. However, there is no local max or minimums. So let's work on this last example here. So it says y is equal to cubed root 5 minus 4x minus x squared. So just split it to the bottom of this section. So it splits up these two questions so we're clear. So initially, if we here we have y is equal to cubed root 5 minus 4x minus x squared. Here we can rewrite it as 5 minus 4x minus x squared to the power of 1 over 3. Here we see that if we factor the inside, so we make that equal to 0 and then factor the inside. So here we'll see that there's two roots, one at x is equal to 1 and another one at x is equal to -5. So keep that in mind as we work through this problem. Next thing we'll do here is we'll derive this function. So we'll do the outside, so 1 over 3, 5 minus 4x minus x squared, power of -2 over 3, and then we'll derive the inside, which will be -4x minus 2x. Here, if we rewrite this, and we'll make it equal to 0, we have 2x minus 4 over 3, 5 minus 4x minus x squared to the power of 2 over 3. And so if we make that equal to 0, again, we see here that -2x minus 4 will be equal to 0, and x will be equal to -2. So here, if we put it on a number line, so we have a couple of points here. So here, -5, -2, and 1. Here, if we look at our critical points of -5, -2, and 1, and we sub in a value, for example, -6, we'll see here that from negative infinity to -5, it will be increasing. We sub in a value of -4, or sorry, -3 or -4, we'll see that it actually continues to increase from -5 to -2. Then only after -2, if you sub in a value like 0, then it will start to decrease. So decreasing from -2 to 1, and then it decreases as well from 1 to infinity. Okay, so here, what we'll see is that there is only, right, there's a local maximum at x is equal to -2. And then what we can do here is we can sub that back into the original equation. So here, if we put in cube root 5 minus 4 times -2 minus -2 squared, and about 2.08. That will be the point. So at -2 and 2.08 will be where our local max is. Okay, so let's look at this last question here. It says determine the function of the form f of x is equal to ax to the power 4 plus bx squared plus cx plus d with a local maximum at 0 and -6 and a local minimum at 1 and -6. So first thing we'll do here is we will sub in f of 0 is equal, again, to -6. So here we can write -6 is equal to a times 0 to the power of 4 plus b times 0 squared plus c times 0 plus d. So here we see that -6 is equal to d. So -6 is equal to d. And here we know again also that f of 1 is equal to -8. If we set that in, we have -8 is equal to a 1 to the power 4 plus b times 1 squared plus c times 1 plus d. So -8 is equal to a plus b plus c. And we know that d is -6, so we can sub that in. And so -2 is equal to A plus B plus C. And the next thing we'll do here is we'll take the derivative. So f prime of x is equal to 4ax to the power of 3 plus 2bx plus c. We'll make f prime of x equal to 0. And so we'll look at it at 0, 0. So here we have 0 is equal 4a times 0 cubed plus 2b times 0 plus c. So here we see that 0 is equal to c. And so we can sub that back into this equation. So we'll be left with -2 is equal to a plus b. Here we can also sub in, again, prime of 1, we know that is equal to 0, because we know that there is a local minimum there. And so here, we'll actually sub this in 0. So we know that f prime of 1 is equal to 0. And so here, 0 is equal to 4a times 1 cubed plus 2b times 1 plus c. And so here we get 0 is equal to 4a plus 2b. So here we have two equations, two unknowns. So here we'll use elimination. What we'll do here is -2 equals a plus b. We'll multiply that by 2. So here we can get rid of the b value. So we have -4 is equal to 2a plus 2b. And on the other side, we have 0 is equal to 4a plus 2b. And we'll subtract those. So here we'll get -4 minus 0, which is still -4, 2a minus 4a, -2a, and then the two b's cancel out. So here we get 2 is equal to a. So 2 is equal to a. Sub that back into the equation. We see here 0 is equal to 4 times 2 plus 2b equals 8 plus 2b, and therefore b is equal to -4. So here we see that a is equal to 2, b is equal to -4, c is equal to 0, and -6 is equal to d.